So we saw in the factorial ANOVA and stata that there was a significant interaction between the alcohol factor and the gender factor. And so that indicates that the difference in the attractiveness rating between men and women is a function of alcohol intake. Or we could reverse that and say the difference between the various alcohol intake levels is a function of whether you're a man or a woman. So at this point, I want to make sure that if you have any questions, please post them into Learning Suite, and we'll make sure we cover them in class about how to interpret that interaction. Okay. Now we're going to decompose this interaction using a technique called simple effects, or an approach called simple effects. Okay, and we can ask, okay, we know that from the interaction that there's a difference, but what's the nature of that difference? Okay, which levels of alcohol have the biggest or smallest differences? And are men and women actually different only at some levels of alcohol? Okay, because if you remember back to some of the box plots, there really weren't that many differences when there was very little alcohol, but it got much bigger when there was more alcohol. Okay, so that's really what we want to understand. So the F-test doesn't tell you that. The F-test just tells you that there's a difference, so we have to decompose it into what are these things called simple effects to be able to explore what these differences are. So what we're going to do is we're going to compare the levels of a given factor. So we could say we compare the levels of A at specific levels of B. Okay, so we're going to say A1 versus A2 at B1, A2 versus A3 at B1, and so on, right? And so what that really means is, like, we're going to compare. So if we take gender, we're going to compare the men versus women, but we're going to do it first just at the 0 alcohol level. And then we'll do it at the 2 pints and so on. Okay. So over here on the left, I've got our design, right? We've got our A and our B factor. We've got the levels of alcohol, the levels of gender, and each of the cells written out here. Okay. So I want you to think about how many simple effects based on the definition that we just had are there going to be for men versus women, and how many simple effects are there going to be for the different levels of alcohol. So go ahead and pause the video and think about that for a minute. And I'm just looking for a number. How many of each of these is there going to be? All right, now that you've had a chance to think about that, what we end up with is 3 for this and 6 for this. So let's walk through what each of those things are. So let's do the men versus women, because I think this one's the easiest one, because we just have 2 levels of gender, okay, in this study. All right, so we're going to compare men versus women at a specific level of alcohol. So it's going to be A1, B1 versus A1, B2, right? We're going to compare those means because that's at the none level of alcohol, okay? It's at the 0 level. So we're going to make that contrast. That's one of them. The second one is this contrast, and the third one is this contrast. So there are 3 simple effects, 3 contrasts of women versus men. Now there are 6 for alcohol. Okay, so there's 1 versus, one of them is this one versus this one, none versus 2, none versus 4, and then 2 versus 4. And notice all of those are at a specific level of gender, because that's the definition of a simple effect. And then we have the same combination over here, right? So you end up with 6 total. Let's move on over into stata. We're going to use contrast, which is a function or a command in stata that will allow us to estimate simple effects, but it also, since we're doing a lot of comparisons here, it'll allow us to deal with the multiple comparison problem. So what you're seeing on the screen right now is the factorial ANOVA that we fit in the last video. So we have the interaction here, right, that is statistically significant. And then I've gone ahead and run the margins command again so we can get those cell means. And then now I'm just going to run the margins plot. Okay, so we can look at this. So the first thing I want to do is I want to compare we're going to actually compute some simple effects, but I just want to make sure everybody understands what we're going to do. So we're going to compute the simple effects that compare the men versus women, right? The red versus the blue at each of these. So basically we're going to get a t-test. It's an adjusted t-test, but it's a t-test that's going to compare these two, and then another one that does these two, and then another one that does these two. And then this will allow us the contrast function in Stata, or command in Stata, is going to allow us to correct for multiple comparisons. Okay, so what we're going to do is we're going to do simple effects. So we're going to do men versus women. Okay, so the way you do that is you say contrast gender, because that's our factor, and then you say at, so the at sign, alcohol. Okay, and I'm going to add the option effects. This is going to give us our p-values and stuff like that. And then what we're going to do is go ahead and run that. Okay, so you can see that this is men versus women is the way it's coding it here. Okay, so what this means is that if it's positive, so when this is positive, men were higher than women, and if it's negative, men were lower than women in this case. So when we're making the comparison between men versus women with no alcohol, the attractiveness rating for men was a little bit higher than women. But then we see down here that when it's men versus women with lots of alcohol, then the attractiveness rating for men is quite a bit lower. The null hypotheses for each of these things is that there is no difference at that level of alcohol, right? So for these first two, we fail to reject the null, but down here we reject the null hypothesis. Okay, so this gives us our test. You've got an F test up here. For the most part, I just ignore this. It's not for the kinds of things that we typically do in this class. They're just not going to be that relevant or interesting. Okay, the next thing we're going to do is the alcohol simple effects, and so we're just going to continue this, but say alcohol at gender, and we can just use the exact same options here. Go ahead and run that, and there you go. Okay, you get those contrasts down here. Notice you only get 4 of them because it's going to just make the contrast between a level and the base. If you want to change the base, our base 2 should use the 4, I think, as the right, so you get none versus 4, 2 versus 4. Okay, so this is that last bit that we didn't get before, that 2 versus 4 from the other one. But you interpret it the same way, right? You're just looking at each of these null hypotheses is that it's 0, and then you're going to test whether there's, or you're going to use this to test whether it's statistically significant.